Hi guys, welcome to Tech Geek. So today we are back with the daily Leetcode challenge problem. The problem for today is number of submatrices that sum up to a target sum. So it's basically the questions which you have done to find an array or anything or prefix sum that tells you to find a sum that's typical or equal to that particular target. So that's similarly the same based question. Okay, so we'll see ki, how to approach this. So this is a lead code hard question. Okay. Okay. So let's see, this question is lead code hard 1074. Before beginning, I'd like to request you all to please like, share, and subscribe to my channel. I've shared various videos on interview experience, internships, and upcoming placements. So it would be good if you guys could go through it, tag your colleagues, friends, whosoever, find them equal. And I'll be posting more for 2023 batch 2. So do have a look on this. Let's see what the question says. The question says in a matrix, we are given a matrix as well as a target. So we need to find number of non-empty matrices that sum up to a given target. Now what is a matrix? Matrix, they have told in submatrix would be set of all the cells that between these values such that all x and y would lie between its number of rows and number of columns. Two submatrices are different if they have some coordinates that are different. Let's say for all of this, they could be different if all are same except one. Okay. Now they have given you a few examples. So for this example, if we see, okay, we have been given this matrix and they say that you need the sum of 0. So very first, take out all the elements with the same target. So we got 4. So 4 1 into 1 matrix could be there. Okay. Let's say there was just minus 1 also. Okay. So in that case, this is also one of the matrices that we'll get. You cannot take this or in this diagonal way. Why? Because it should be kind of an array, 2D array you can say, 2D or 1D array depending on how. So we, if firstly in that case we have 4, but if we have a minus 1 then we can have one more, that's fine. Now let's look at the solution if our target was 4. Okay, so the very first thing is to calculate or to remove all the elements with 4. We just have 1. Okay, now we'll traverse like this. That's a row wise. Okay, 0 not possible, 0 not possible, 1. Now take the sum. By this it's 1. Is it equal? No. Take another one. Is it equal? Yes, 4. And for this also we'll have 0 0. So the one of the matrix would be this. Now we'll come back and check 4 minus 1. Is it equal? No. Okay. Similarly, we'll check 4 1. Now 4 minus 0. Is it 4? Yes. So this will also be this. Like excluding 1 and we'll get 1. Again excluding 1 and getting 1. So what we are doing, we are taking a row, removing one of the elements and then checking is the sum equal? Yes. If it is, then increment the counter. So initially we got 1 and then we got 3 from this row. Let's come like this now. Again 1, no. 1 plus 4, 5, not possible. So obviously it's increasing, so but it could be possible there could be a negative number too. So let's add up. Then 4 plus, okay, 1 4 and then 8, no. Again coming 10, not possible. Now remove, try removing it also. Like you can remove 1 and check for this. Is it possible? No. Again do the same thing. Coming from this, let's say, okay, again in this we can see there's no such possibility row wise. No. Once you got this solution, that means you have the, okay, let's say we have these sum together all together. Okay, sum in a column wise way. If we have these sum, The sum would be like 0, 0 plus 0 is 0, then 0, 1, and this will become 4. We are adding in a row column, okay? 4 and then 8 and then 10. Again the third one as it was 0, 0, 0, so this will remain same. Okay. This is how we got the sum. Okay. Now again we can see in this way if we wanted to confirm like yeah this is the row wise solution. So very first is take out 1 and this is to find the number of rows. Okay. Now what we will check now is a column wise solution. Check with 0, 1, 0. Possible? No. 0, 4. Yeah, 0, 4, this is possible. Again 1 you got. 0, 4, 0. Yes, this is also possible. Take out one more. So the same way we did for row, we'll do for column. Come here. 1 not. 1, 3. Yes. 1, 3, 0. Yes. So 2 you got from here. Now 2, 3, 5. Not possible. 5 plus 2, 7. Not possible. But what we can do if we remove the 3, 7 minus 2. Yes, 1 is possible. So what we'll do, we'll iterate, take the prefix sum in row and then in column and then check in the same way. Okay. So that's how the solution we got is 4, 5, 6, 6, 7, 8, 9. Okay. So what you have to do, find the prefix sum, check for all the possible matrices that will sum up to the given sum. That's what you have to do. That will. Now let's look at the solution. It could be pretty confusing, but once you code, you get the solution. So we've taken a row, column, result. We took the addition of these numbers. That's we're finding the prefix sum. Then in a submatrix, we add this, store this in a map. Now all the sums which we are getting, we'll be storing it in a map to store that is sum and its occurrence. Okay, so that you can directly give the occurrence of that particular sum. We'll be storing it in an integer format, finding the sum, and we'll add it up and check whether the prefix sum is equal to that. If it contains that target, we have the submatrix sum and the target. If that's already there, then in that case we can get the answer. So this is easily understandable if you know how to do it. Could be tricky if you are still confused, and this will go up to order of nm, that's row into column. Okay, and into again n, because we are taking the rows again and we are iterating accordingly. So this could be complexity. Yeah, you can even go for the DP solution if you want. That would be quite easy according to your choice if you're not getting this, but according to me the HashMap solution would go up in a very well way and will give you the efficient answer, and it's quite understandable, so that's why I chose this. If there is any query, then do let me know. Thank you.